Welcome to another Explainer. Today we're looking at a scenario that is incredibly cinematic, highly energetic, and honestly, kind of terrifying. We are tackling the ultimate cosmic what-if. I want you to step into a situation that is essentially the worst piece of downloadable content, the absolute worst DLC in the entire history of the universe.
So, what if the sun just disappeared tomorrow? No, really, think about that for a second. Imagine waking up tomorrow morning. You stretch, you walk over to the window, you pull back the curtains expecting that warm golden light to pour into your room, and instead, nothing. No sunrise. Just absolute pitch black darkness.
Now, your very first thought is probably going to be something like, great, my alarm betrayed me again, right? You'll just assume it's the middle of the night. But nope, you check your phone and the time is completely right. The reality is far, far worse. The sun has officially resigned from its post, and it didn't even bother giving us a 2-week notice.
Okay, let's dive into this, because this is exactly where the science gets incredibly fascinating. See, Hollywood totally lied to us. Again. If you watch big disaster movies, you might think Earth just instantly turns into a giant ice cube the exact second the sun vanishes. But the scientific reality is that light actually has a cosmic speed limit.
It takes exactly 8 minutes and 20 seconds for light to travel from the sun all the way to Earth, which means we have an 8-minute buffer. For those 8 minutes, everything on Earth looks perfectly, totally normal. People are making their morning coffee, kids are running late for school, someone out there is probably posting a photo online with a caption like, "Beautiful sunrise today." Little do they know, they're looking at a ghost. The sun is already gone.
But then we hit that exact moment, minute 8. And the buffer runs out. The sky suddenly goes completely black. Not cloudy, not just nighttime, just space. Imagine standing outside, looking up and seeing a full blanket of stars at exactly noon. For about 5 seconds, it would be absolutely breathtaking. And then, the instant global panic arrives.
But here's the wild part. It's not just the light that takes time to get here. There is this fascinating physical reality called gravity delay. Gravity literally travels at the exact same speed as light. That means Earth just keeps happily orbiting empty space for those same 8 minutes and 20 seconds. But the very moment the light disappears, that invisible gravitational leash holding us around the sun, it simply snaps. Simultaneously, Earth instantly shoots off into deep space in a straight line. No more orbit, no coming back. We are officially a homeless planet.
So what actually happens next? Let's move to the timeline and see how this builds, because we need to look at the chronological survival of our newly rogue planet. What unfolds in the hours, the days, and the years after the lights actually go out?
Let's start with the first stage. In the first few hours, surprisingly enough, we wouldn't freeze instantly. Our atmosphere and our massive oceans actually store an enormous amount of heat, so the global temperature would only begin to drop gradually, which means, ironically, your Wi-Fi is probably going to die before you become an ice cube. Talk about modern priorities, right?
But unfortunately, that comfort doesn't last long at all. Moving into the first week, we had some incredibly bleak milestones. Within days, global temperatures fall below freezing. Power grids begin to struggle massively under the immense strain. And those expensive solar panels on your roof? Yeah, they become very expensive, completely useless decorations. Plants completely stop photosynthesis. And honestly, the whole phrase "let's touch some grass" loses literally all meaning, because everything on the surface is dying.
Fast forward 1 year later and we hit a brutal new reality, -70 degrees Celsius. That is our new average global temperature. At this point, the world's oceans are actively freezing over, starting right from the surface and working their way down into the dark.
Now, what's really interesting about this slide is deep ocean survival. Beneath all that ice, the deepest parts of the ocean actually stay liquid for a surprisingly long time. This is all thanks to Earth's internal geothermal heat bubbling up from the core. Down there, near hydrothermal vents, life could just continue. Tiny organisms might outlive human civilization entirely. Mother Nature basically just looked at the sun disappearing and said, I'll manage.
But what about us, right? Could humans manage? Well, we could only survive if we executed a massive global science experiment. We're talking about a blueprint where we build massive underground cities, tap into that same geothermal energy, utilize nuclear reactors, implement totally artificial farming, and rigorously recycle all of our air. Suddenly, having a boring, windowless underground office job really doesn't sound so bad.
And throughout all of this absolute chaos, what about the moon? Well,
It's still there, just floating right beside us. Because the moon just reflects the sun's light, it would go totally dark the exact moment we do. It's basically like that friend who watches your entire life collapse, stands there in the dark, and just deadpan says, "Damn, that's crazy."
Now you might be wondering, why can't we just find a new sun? Could another star replace ours? Well, the science shows that the nearest star, Proxima Centauri, is over 4 light-years away. So the reality of trying to reach it, it's literally like losing your house to a disaster and someone comforting you by saying, "Hey, don't worry, there's another apartment on Mars." I mean, yeah, it's technically true, but practically completely useless for a frozen rogue planet.
So the crucial point is this. The sun isn't just a bright object in the sky. It is every single sunrise you've ever seen. It's every tree, every breath you take, every meal you eat, every drop of rain that falls, and quite literally, every civilization in human history. Without it, the Earth doesn't explode in some massive, dramatic Hollywood fireball. It simply, slowly becomes silent, cold, dark, and entirely empty.
The universe doesn't need us to survive. We need one ordinary-looking yellow star. So, tomorrow morning, if the sun actually rises, take a real moment to appreciate it. But it does beg the question. If our star is so ordinary, how many other billions of planets out there are relying on their own yellow stars right now? Thanks for learning with me today on this explainer, and I hope you never look at a sunrise the same way again.